session and the selection committee to give me this opportunity to present our work and research done in the field of lead intoxication in modern India. Lead intoxication continues to be a major public health menace. The WHO, the World Health Organization, estimates that middle and low-income countries carry the highest rates of elevated blood lead levels in the children population. 74% of all the disease burden lies in Southeast Asia, comprising majorly from India and China. A recent study done by Tana et al. From New York University estimated that almost $1 trillion are lost every year to lead poisoning in the developing countries. We hypothesized that aiming to investigate that there is a high prevalence of lead intoxication in children between 0 to 16 years in India, more than a decade since the abatement of lead from gasoline. We aim to find out the changes in the blood lead levels after cessation of usage of leaded gasoline in modern India, along with evaluating the impact of drinking water on the prevalence of lead intoxication in modern India. These pictures depicting improper disposal of lead waste is not an uncommon sight in today's India. Ours was a cross-sectional environmental study piloted in semi-urban northwestern India. Just to give an overview of the geography, India boasts a total population of 1.2 billion people. Jaipur, which is the site selected for our study, was selected because it is the most closely representative in the entire subcontinent with respect to age distribution, demographics, social economic status, and ethnic composition to the entire country. 20% of this 3 million total population comprised of children between 0 to 16 years age group. Furthermore, along the presentation, you will see that Jaipur derives its water in a manner similar to the entire country. The sites for sample selection were carefully selected to get a representative cohort for the study. As visible in this slide and the next, samples were pretty evenly selected from the entire region for a good demographic cohort. Plasma mass spectrometry was the technique utilized to assess the plasma lead levels in children under strict CDC guidelines. Cost per sample was $15 United States, and the usual turnaround time was 4 to 5 days. As shown in this graph, the age distribution, a third each of subjects were represented in 4-year increments as 0 to 4 years, 5 to 8 years, 9 to 12 years, with a small number in the age group of 12 to 16-year subjects. The mean age of sample study was 7.3 years, with a standard deviation of plus minus 4.9 years. Given the prevalent societal norms with a neglected girl child, sex stratification in our study was skewed, with a 4 to 1 male to female preponderance. As shown in this pie chart, 55% of children had blood lead levels above the CDC level of concern, which is 5 micrograms per deciliter, out of which 37% had blood lead levels above 10 micrograms per deciliter, and the remaining 18% had levels between 5 to 10 micrograms. Correlation of this elevated blood lead levels with age group less than 8 years was found to reach statistical significance. This is especially worrisome, as the damage to the maturing nervous system is the most lethal during these growing years. As visible from this pie chart, 44% of the sample subjects derived drinking water from domestic wells, and 56% of the remaining sample got their drinking water from public water delivery systems. As is visible, despite the difference in the source of the water, environmental contamination is virtually identical irrespective of where the source is. Displayed here is the blood lead level distribution across the sample population in this modern era. Of note, 45% of children in our study population had the levels within the CDC acceptable limits. This improvement is particularly noted when blood lead levels pre and post leaded gasoline era are seen back to back. As is visible in the pre-lead abatement era, only 20% children had CDC acceptable lead levels of less than 5 micrograms as compared to the post-lead abatement era, in which this percentage has increased significantly to 46%. This is a significant public health victory, but there is still more to do. A serendipitous population of 38 children with developmental delay appeared in Jaipur that had access to advanced water filtration systems in their houses due to the prevailing notion of heavy metals causing developmental delay. Neurological disabilities secondary to this preconception led to the parents to install reverse osmosis filters, which virtually eliminates any heavy water in drinking water sources. As a result, significant decrease in blood lead levels were seen from children as compared to the ones that had access to unfiltered water. In summary, since beginning of abatement of lead from gasoline, the mean blood lead levels have significantly fallen from an average from mean of 12 micrograms to 8.9, out of which the water filtration was shown to reduce the blood lead levels from 10.5 to 6.8 micrograms. This identifies two major culprits of lead contamination in the country. To conclude, effects of amelioration of lead from gasoline resulted in a significant reduction in the mean blood lead level, partially highlighting the problem. Drinking water in India appears to be contaminated irrespective of what the water source is in the house. On further collection of information, we found that accepted lead levels for WHO for any groundwater in any area of the world has to be less than 50 micrograms per liter, which was found to be almost double in Jaipur at 100.5 micrograms per liter. Results point towards contributing factors to blood lead levels, but there are other players. The likely remaining culprits, which were identified, were leaded paint, which are used to decorate walls, toys, utensils, and swings in the parks, where children spend most of their times outdoors. Ayurvedic medicinals, which is a big part of Indian therapy, have been found to be heavily contaminated with lead. Spices and condiments used across the subcontinent has been found to have commercial adulteration with lead, given the fact that lead is an inert inorganic chemical. Burning of fossil fuels, which remains the chief source of energy in domestic households in rural areas, also adds to the problem. As an outcome to our study, we produced a white paper with policy guidelines released for standard lead screening for all children in pediatric centers across the country. Reverse osmosis filters have been provided to the families with elevated blood lead levels as a result of our pilot study through the Government of India. We entered into a lead abatement collaboration with the World Health Organization and the Government of India to further the efforts. This model of ours has been adopted by the Nassau County Department of Health in New York to counter the recent upsurge of new cases of lead poisoning in the county. Our next study will be to refine this data and determine the effects of our intervention and see and evaluate the other sources of environmental lead poisoning. I think I have some time for questions. Thank you so much for your attention.